Shit on? Is this shit on? Is it on? Okay. What's up, Amsterdam? God, I love this place. I'm Ken Wheeler. That's Ken_Wheeler on Twitter if you feel like reading a bunch of garbage. I think some people like some of my tweets. You know what I mean? And I work at a company called Formidable, which is a JavaScript consultancy based in Seattle, but I don't work there. I work from home in New Jersey because I'm an HR liability. So I was here last year, and it was awesome. I was really lucky to be here last year. And I talked about fiber renderers. And it was pretty fun. So fiber renderers are custom React renderers. If you think about something like React DOM, where that renders, oddly enough, your DOM. Fiber renderers can take components and render other things and have other base primitives. Jeez. I don't know what to do with my hands. They have me mic'd up, dude. I feel like Tony Robbins or some shit. So yeah, they're custom React renderers. And you can render pretty much whatever you want. Like the way that the DOM renderer gets a piece of HTML and knows to update HTML with a bunch of browser APIs that nobody uses anymore. You could do the same thing with almost anything, right? So you could either extend the built-in DOM renderer, if you want to do something custom with your HTML, or you can write a new one that you just React kind of renders to whatever you want. So when I was here last year, I did an emoji renderer, right, which was an extension of the DOM renderer. And you would type things, and if it saw a word that was recognized as being emojifiable, it went ahead and emojified it. So that was an extension one. And then I did a thing called React Synth, where you could use special tags, which are the components of a analog style synth, and via the props, via the components, it would put together a playable synth, right? I had a Logic Pro open, doing it with MIDI, and it was pretty tight, right? But what if you need to mix more than one thing, right? If you have one of these renderers, a lot of the time it's just DOM, or it's just React Native, or it's just this synth thing, right? So you could do something like this, right, where you have your, it's my selection show, yeah. So you have a container, right, and you're doing something in there, and you React DOM render that, and then you could do a separate render here. But that sucks. I wouldn't do it. I wouldn't feel good about doing it, right? And I'll tell you exactly why that sucks. So you're importing 2 or more renderers, which that sucks. It's two non-portal rendering paths, right? So that it's not cohesive. They don't really work together. It's just you do the one and then it splits off into the other. So what can we do about that? A thing called renderless components, which is, I don't know if that's a really accurate term. Oh, fuck you, dude, are you kidding me? Personal email is out there in the wild. Yeah, renderless components. So they're they're not, sometimes they actually do render things, but a lot of the time, what they're really doing is just kicking off side effects that aren't part of the DOM renderer regularly, right? So UI is not just your divs and spans. React is the UI layer. Well, not really anymore, but I guess that was the original billing. But there's a lot more to UI than just your HTML. All kinds of things are UI, right? Things like web audio could be part of your interface. Things like Canvas, WebGL, almost any non-DOM browser API. Matter of fact, your side effects can be any non-DOM API period. You could do a lot. So just to give a really simple example of how this works, is something that you might have even done before, just super dumb little components like a redirect, right? When this component did mount fires, this will just redirect you to the prop right here. You could throw that in a render path and it'll redirect you. You could have a short circuit operator, if they're not logged in or something like that. Or you could just use React Router like an adult. And then you could have something, easy now, you could have something like this, which I've actually used this pretty often, is a log component. So if you don't feel like doing some weird console log thing, you could just create a log component with a value and put it as part of your render path. But that's not really what I'm here to talk about today. Neither is this, but I'm still going to go through it, which is a more intermediate level. Like those first ones are so simple. This one, right, ups the ante a little. So if you wanted to do something like a D3 chart in Canvas, right, a lot of the time you're going to go here, you're going to render your container and put a ref on it, and then up here you're going to have your data come through, right? You're going to have the derived state from props. I'm using it, Dan. Deal with it. And it would call like format data, and then you have a responsibility here when you're forking off, right? When it's not going directly to the render. In your update and your mount, right, you're going to do the draw chart because you want to make sure that, and you're going to use the derived state from props because you want to make sure that when new props come in, right, if you have this thing that's not, automatically updating like a render would, you got to keep that in sync. You got to update it yourself, right? So if you're going to use these, right, they don't automatically update. You want to initialize whatever you're doing in component did mount, and then in component did update, that's where you're gonna update if new props came in or something like that, right? So now it's time to talk about some complex ones, right? So the kind of scenario that you'd be in would be if you had like arbitrarily nested subcomponents. Like if you I'm writing this presentation in Spectacle, which is a React presentation framework that I wrote. And it kind of just relies on stuff being like child elements, right? But if you have something that has some undetermined depth of where you're going to put things, that would be a scenario. Relationally nested subcomponents, so things that kind of work together based on their position in the tree. And multi-component non-DOM composition, right? So if you want to take an API that's imperative, make it declarative, and you want to have a bunch of different components come together to compose, something that you would normally write in a line, this is how you would do it, right? So let's talk about how to reactify non-React things. So look here, this is like context, like a pretty simple context example, right? You grab your container, you get the context for drawing, and then in this animate function, you just set your fill style, and then fill a rectangle, and then this is on a loop if anything updates, right? But that's just not how I write code anymore. Wouldn't it be nice to be able to write it reactively, right? Where you have a canvas component with your height and width, you have props on all this stuff, and it works nicely, right? So doing that is not magic, it's context, which in my opinion is the best part of React. If you use context and use it as the tool that it is, you could do crazy things with it. So let's talk about some basic context, even though I guess the previous talk talked about some basic context. I'm just going to really drill that home. Yeah, so like for an example, like a theme here, right? You import it. I do a create context. You don't have to put in an initial value. This is just going to be like a color provider, right, for like a theme. And you export your provider and consumer there. Whoopsh. And then right? And then in your in like your top level of your app, you have your provider, and you can pass through this right here. Oh, this object literal. Don't ever do this. But yeah, I'm doing it just to keep things terse, fit them on the slide. So you could pass down like an object here, like color is green. And then in a child component, if you want to use that, you just use the consumer, right? And then you have the child render prop here, and you can console log it out. So what context lets you do is teleport things through your tree, right? And with the new context, what's nice is if you were back up in the top one and you had it in state, oh my god, oh yeah, no, I haven't. I thought I screwed up that. Yeah, here, like if you were to update your state, right, it's going to update the context, and anything that wants it, that's going to update in turn. So you can pass almost anything down via context. You see it used a lot for like theming and internationalization and things like that, but functions, references, anything. And I like to build some of the dumb things that I do with React via a thing called the registration pattern. I don't think anybody calls it that. I'm just calling that, so maybe we can call it that. So you initialize a module in your top level component, right? You pass a function through context to the relevant children. It's not going to go to every child. Just any child that's wrapped in the consumer would get it, right? And then the children use it to register with the parent, right? So if you have a module in a top level and then you have a child like 3 levels down, when that mounts, it already has a function from the parent passed by reference to it, and then it can call it, and it's like, here, I'm here. And then the parent can then, build with it knowing that it's present. Right? So this is an example of what that actually looks like. If we had a register, when I highlight this, it just makes it so not legible. You have a register function here that'll push items into an array, right? So if you had relevant items down at any level of the tree, and you want to collect them in this top one, you have this register function, and then you set the context value here right on the instance. Register is this register, and then your provider, you just pass that down, right? So this will go to anything. So then if you have a child component, also if you're worried about the render props on context, this is a good way around it, is just to create a little wrapper here, and then you can use it regularly. But here I have the register, I pass it down to the child. In component did mount, I have this thing, when it initializes, it creates its own UUID. But then in component did mount, it registers itself, and now the parent knows that it's there, and then can, do actionable things based upon that. So there's another pattern here, where you do the same sort of thing. You initialize the module in the top level component. You register a callback with the parent from the child, right? So you can keep any logic for what that child represents in the child. You're passing the callback up to the parent, and then when the parent renders, it can all the callbacks that have registered with it, you can then call those, right? So here, same sort of thing. You have this, except we have a draw method in the parent where I'm saying for each item that's registered, call the item's callback, right? When you head down here, right, you register this .callback, and then in here you could do whatever you want. You could draw stuff, etc. Right? Oh shit, it's demo time. Okay, so I'm going to show some examples of this real quick. Okay. So I think Canvas is a fun one. Is this font size okay for everybody? Can somebody say no if it's not? It's all good. Okay. So for Canvas, right? If we wanted to have Canvas and we wanted to represent it in this sort of declarative, like tag-based API, I sketched this out where you can have you have your canvas with your height and width, and then you have a box, right, which is going to represent a rectangle in Canvas. Canvas doesn't actually have individual elements or a DOM, right? You're kind of just your immediate mode drawing to it. So it's like the second pattern where you're doing the drawing. I have X and Y, which are based off of state, and then I have mouse down, mouse up, mouse move. So you're putting events on elements that don't technically exist. And then up in here, all this does is if you are dragging one of these boxes, it'll get the distance and essentially let you drag it around, right? So how do we pull this off? Right? So here's the top level canvas right here. And what we want to do initially is wrap our provider with the context value, right? So our canvas, we're baking a provider into the canvas. Right? So when this renders, it renders that context without anybody even knowing about it. And then it has a canvas element, regular HTML. It takes these props and it has a ref on it. And then we're going to do the events because, again, they're not real elements. They don't have events. So what you need to do is you need to do like event delegation style, where you're getting the events on the parent, making sure that they're inside of the child, and then you'll be able to do it. So then we render this.props.children. Right? So just to show up in here in the component did mount, I get the context and store it on the instance. I have the canvas ref current get context. And then we call draw. Right? And if we go up to draw, yeah, so in draw, like I was showing before, we have the elements that have registered. We're going to go through, and every time that you draw on an animation frame with Canvas, you want to clear it, right? Otherwise, it's just going to draw on top of it and look silly. So you're going to clear it, and then you're going to come down here, and you're going to iterate through the registered elements, and then you're going to call their draw method that got passed back. If we go look at the box here, we generate an ID for it for identification purposes. Down here, it has its own draw, where based upon props, it's going to go do this. So you have context that gets passed down to this, and it's going to go and it's going to draw some stuff. The coolest part about this, right, this is the consumer that's baked into here. You have the consumer, you have update element and delete element. In here, right, again, Canvas doesn't, they're just elements getting kind of drawn there, but you can render children to the canvas. And you should, because that's how you do accessibility. So here, if I have this input in here. For each one of these boxes, I render an input. I should probably put area stuff on here, but I didn't. It's probably actually not an input either. I digress. It's fallback accessibility UI for the canvas. When I saw React Canvas, I was like, this is like the dopest thing I've ever seen. And then I guess they caught a bunch of flack over it because it wasn't accessible. And I'm not going to be that guy today. So it's accessible. So if you're going to do it, make sure that it is accessible. If we actually, back in box up in the drawer here, this is if you want to do Canvas and you want to make Canvas accessible, what you do is you say draw focus if needed, and you check that on the element that you've rendered as a placeholder for it. And that's how that works. Before I show the demo, I just want to show one more thing here. You have these parent events, the handle mouse move, and the event delegation for the boxes. So it calls this respond to event method right here. And then I go through the elements, and I say, if the elements that we've rendered have like on mouse move, on mouse down props, then check if it's inside the element. If it is, then you actually call the function with the event on those children. So you get this from that code there. And now you can drag it around, and you can work with it like it's React. So no longer are you working with this Canvas imperative API. Now you're setting state, you're dragging things around, you're using on mouse down, on mouse up, and you've successfully translated a imperative API to a declarative one. So you can come here. I don't know if you can see the little things, but I'm like tab focusing these. And if you come here, you can see, oh, shut up. Yeah, so you can see the actual fallback stuff that gets there. So that's how you can have super performant UI here and make it remain accessible. What time is it? Okay, we got time. Demo 2. Okay, so the second one I did was 3JS, right, which is a little bit different because it doesn't redraw every single time. You kind of create stuff and it chills, and then you want to update stuff on it if you need to. So in here, we have a component set up here. This is my 3 demo. So I have a world here, right, a scene, right, which is a 3D world. And I have a click handler on it, and I have a background path, which will give me my cube map to show the world. And then in here, I have balls that I render. Up here, I have a ball count in my state. We're counting the balls. And then when you click on the parent, on the regular thing, we're going to go ahead and increase the ball count by 50. And then if you press the D key, it'll delete 50 balls. And then if you click one of the balls using array caster in 3D space, it's going to alert balls. And so what you do is, here you're going to go and create an array from the ball count, and then iterate over that. And for each one of the balls in the count, you're going to return one of these ball components, which is going to represent a 3D ball in 3D space, right? I should have just made it spheres. But what can you do? Yeah, so here it's like a very similar kind of setup in the scene. We have this init, right, which is like the first thing that happens in component did map, where you set up all the 3 stuff, right? We're setting up like a camera, a raycaster, you're setting up the scene, the renderer, setting all the stuff, and then you call render on the scene with the camera. Also, we have animate here, which through request animation frame, we'll then call render scene here, where we go through and kind of just check things and render them. So we have the child balls. If we go to the child here, it does a very similar thing as Canvas, where it'll go ahead and generate that ID. Except when it mounts, it'll do this add mesh method, right? Which takes the mesh and it has the handle click if you click a ball. I'll give you that. But this just kind of lets you know to render a ball, right? So if I come back up to add mesh, what this is going to do is this is the 3 code to create one of these 3D balls here, and then you can set things like the callback on it, right? So you know that's the specific one, and then you just kind of add it to the scene and push it to the internal array of balls. So yeah, here's our 3D scene, right? And then I can click and just add these fun reflective balls everywhere with WebGL, and it's a good time. You have this raycaster, so you can, that's how it figures out what you're actually mousing over. Yeah. If I was better at like Canvas and WebGL, you'd probably have better demos here, be more involved. But like somebody who knew what they were doing or were like good at design or anything like that, the stuff you could do with this method, I mean, it would be incredible. So I do have one last demo that's kind of fun. So we've been rendering individual things so far, but we haven't mixed any of it yet. And that's what I intend to do. So if we hop back, nice. Okay, yeah, let's close this out. So I have a mixed mode demo. And in here, what I have is I have a scene, right, which is a 3D scene. And then I've bridged audio, a lot like React Music, right, where you have an audio tag here, which is like the audio manager. And then you have these tracks, and each one of these tracks represents a loop of audio that's playing, right? It's got a path, right? And it has on, which means is it playing or not? Is the volume up? And then you have on load, right? So you have to load these resources. So what I'm doing is I'm using this on load to say, have they all loaded? And if they have, then for our audio, we could say that the play is this state loaded. It's time for the audio to start playing. Otherwise, don't start playing. Another cool thing is the analyzer, right? So what we're doing is we're using a web audio analyzer to get the data about the currently playing audio. So we have a register analyzer where we're passing that up out of the audio controller up into the parent here, right? And it's getting put on state, right? So we have analyzer right there. And then it gets passed back down into the 3D scene. You guys see where I'm going with this? And then down here we just have regular DOM elements, right, which are just buttons that will toggle the tracks on and off. So quickly, let's just take a look at how the audio works. Initially, we're going to create an audio context, and then we're going to create our analyzer. That's what we do right off the bat. In the mount, we're going to go and calculate the bar interval. So based upon the tempo and how long the loops are, right, we're going to figure out what our scheduler tick is. We're going to go in, we're going to connect to everything, and then in component did update, we check if it's playing. So I have to say, is props play true, and is it already playing? If it's not already playing, then we call the scheduler start, which will start iterating through the audio loop. Register audio here is how we get the child audio tracks to say that they exist. And then if they do exist, in our loop, right, we iterate through each one of those and do the callback. So if we go look at our track here, we have all this stuff, which kind of just loads everything. And then in our component, we have our callback. So in web audio, you need to create a new buffer every time it plays. So a callback, which would be once per bar, which would be like, and then 1, 2, 3, 4, callback, 2, 3, 4. And that's how that creates that. Right? Yeah, in component did mount, we're using the same stuff that we did before, where you're registering the audio, you're sending the callback back up with the context. Again, this doesn't actually have any backup UI because it's audio, so it just returns null, and that's how I've traditionally done most of this, which is why it's called renderless and not stupid side effect components. But I digress. Yeah, so the scene is a lot like what we saw before, except I didn't do the visualization as a child. I just did it right in here. And I go and I pass in the analyzer. I pass in, nobody's got time for this. Yeah, so if an analyzer came down, I can go and get all this stuff that I copy and pasted from some Google developer document on how to get this, some 8 array, I don't know. And then go through and draw the UI for this. So if we look at this demo right here, we have a 3D world, and we have 3D visualizations. Wait, this shit gets dank. Oh yeah. Wait, the best part, the best part. Wait, the best part, the best part. Yeah, I made that shit, so sorry. Thanks so much, everybody.